Hey guys, welcome back. This is lesson 2.6 about graphing linear equations and inequalities. So we're going to be doing this from both slope-intercept form and point-slope form. So let's get cooking talking about graphing linear equations and inequalities. So first one we're going to graph is this. So whenever you're graphing, first try and figure out which form it is just because it's going to make your life a little bit easier to graph. So this one is clearly slope-intercept form. This is the slope, this is the y-intercept. So if this is the y-intercept, that means I already know one point is right here at 0, -1. So what I want to do from there is I know that this is the slope. So I want to use the definition of the slope to help me figure out another point on the graph. So remember, the definition of the slope is that each time the input increases by 1, the output increases by whatever the value of the slope is. So in this case, each time the input increases by 1, the output should increase by 2. So I should have another point here. Now that I've got my 2 points, in order to create any unique line, all you need is 2 points. So now I can just draw my line and I have the graph of my linear function. So that's it from slope-intercept form. So that is the graph of my linear function, y equals 2x minus 1. So let's take a look at one that's in point-slope form. So this one, I've got y minus 2 equals -x minus 1. So I can tell this is point slope form because the way this is presented, and from the way this is presented, I can also tell that the point, so I have the point 1, 2 on the graph, and that the slope is equal to -1. So I'm going to find the point 1, 2. So I've got 1, 2, and the slope being -1 means that each time that the input increases by 1, so x goes up by 1, the output will decrease by 1. So then I have another point here. Now I've got my 2 points, and I can start connecting them to create my line. So that is how I'm going to draw my line in point slope form. That's good. All right. So we've done slope-intercept form, point slope form. Don't worry, we're going to do plenty more practice with these in class. I just want to make sure that you have the basics of how to do these down before class. So graphing linear functions, we basically just talked about all this. No matter what form it's in order to graph it, you need 2 points. All lines, any distinct line can be defined by 2 points, and it's an infinite set of points that connects those 2 points. So in slope-intercept form, we need the y-intercept, and then we're going to use the definition of the slope to find a second point. In point-slope form, we're going to figure out which point is given by the equation, and then again use the definition of the slope to plot a second point. Then we're going to connect to draw the line. So we're also going to talk about graphing linear inequalities. So this is going to be really similar to graphing linear equations, but we just have to pay attention to the inequality symbol. Remember, inequalities are greater than, less than, greater than or equal to, less than or equal to. So one important thing that's different about linear inequalities is when you're drawing the graph, you may not draw a solid line. So if your equation is not equal to, so if you just have greater than or less than, you're going to draw a dotted line to indicate that that line is not included as a solution because it has to be greater than or less than that line. And then you're also going to shade either above or below the indicated region. If it's greater than, you're going to shade above the line. If it's less than, you're going to shade below the line. So we're going to do a couple examples to see what these look like. So we're going to graph y is greater than 2x minus 1. So we just plotted this a second ago. So this is, I have a point at -1. I go right 1, up 2. And so now when I connect my line, if I notice this just says greater than. It doesn't say greater than or equal to. So when I draw in this line, I'm actually going to draw in a dotted line to indicate that the points on this line are not actually a solution to this equation. And ooh, that was not even close to where it was supposed to go. So in order to demonstrate that this is true, let's just take a point. Let's take this point right here. We're going to take the point 1, 1. And we're going to plug 2 times 1 is 1 minus 1 is 1. 1 is not greater than 1. 1 is equal to 1, which means that this point is not actually included in my solution, which is why this is on a dotted line. So the second thing that I want to do is I notice that this says greater than. So if this says greater than, I want to shade everything above this line, which in this case would be everything in this entire region of the graph. So any point in this region of the graph would be a solution to this inequality. So what that means is let's just take a point here like negative 1, 2, right here. We're going to take this point, negative 1, 2. If I plug it in, 2 times negative 1 is negative 2, minus 1 is negative 3. So I've got negative 2 is greater than negative 3, which is true. So anything over here is a solution to this linear inequality. So here's another one. We've got y minus 2 is less than or equal to this. So this time, this is in point slope form, and we just graphed this a second ago. So I've got the point 1, 2. And then I'm going to use the definition of the slope. So this time it says less than or equal to. So I am going to use a solid line here. And I'm trying to do my best to draw a line on this. There we go. So we are going to use a solid line. And I apologize for my terrible line, but we're going to pretend like that's a straight line. So since this now says less than is everything below the line. If you're not sure which one is above and which is below, one tip is to take your pencil, put it somewhere on the line. If it's below, go down. Everything in that portion of the graph is below. If you go up, everything in that portion of the graph is above. So this whole section is solutions to this inequality. And we can try this, and one easy point to try here is 0, 0. So if I plug in 0, 0, I get negative 2 is less than or equal to 1, which is true. So this is to help you remember if your line is solid or dotted, if you shade above or below. Just remember, if it's not equal to, it's dotted. If it's greater than, you shade above. You shade above, not shave. You shade above. And if it's less than, you shade below. So that's it for today. Today we talked about graphing linear equations, and we talked about using slope-intercept form and using point-slope form. And for some reason, I guess the graphing linear inequalities just got deleted off of this page. But we also talked about graphing linear inequalities. So I hope you took some notes. Hope that you're ready to come with some questions. And I hope you have a fantastic day. I'll see you next time.